Good evening and welcome back to the next video lecture in our Step Up Bengal group. We are discussing expressions for kinetic energy for CSIR net oblique set math. For math background student, this classical mechanics, as we have already discussed in our previous lectures from lectures 1 to 7, very important topic. Those who are new to this video lecture, please revise all the lectures in L1 from L1 to L7. এখন প্রশ্ন আসছে যে spherical polar coordinate system আমরা আগের দিন take a look at the last topic, just we finished here. We are going to establish expression for kinetic energy T in spherical polar coordinate system and cylindrical coordinate system. So in polar coordinate system 2D, we have already seen how kinetic energy is expressed in terms of r dot and r square theta dot square. Now when we would like to write this expression again here, that means kinetic energy equal to half into m into r dot square plus r square theta dot square. Now comes first, we will briefly see what is spherical polar coordinate system. আমরা খুব সংক্ষেপে দেখব spherical polar coordinate systemটা কি হতে পারে। তো তার জন্য let us draw some simple configuration of this particular system, that means spherical polar coordinate system. This is the configuration. Say a particle is here whose Cartesian coordinate is xyz, but in case of Cartesian coordinate we will use another different type of concept, that is called r theta phi system. Here we see three distances. Here one distance r, one angle theta and one angle phi. So starting from origin, we will finally like to go at P using not xyz in conventional Cartesian three-dimensional system. Here we would like to use these three. So first of all, we would like to join rather O to P, that is R. This first quantity R is thus defined. Next we would like to drop a perpendicular here. This is N. This is the base of the perpendicular. এটাকে আমরা এই পারপেন্ডিকুলারটার বেস বলবো। আর খেয়াল রাখবো, just take a look at the fact that this is an angle which will be denoted by phi. So this phi is defined. So phi, what is phi? Phi is its angle with x-axis. That means this particular plane, if we consider this triangle as a plane section, then phi will be this angle. And finally we would like to see that there is another angle already created by this figure. That means OP, the angle OP is making with z axis, that is called theta. So we have finally defined these three quantities. Now in three-dimensional system, this concept of two-dimensional polar coordinate system becomes spherical polar coordinate system, because if we consider here a sphere, then on it the most suitable configuration will be this system. So kinetic energy in spherical polar coordinate system is, say if we have to deduce it, then the process would become lengthy. That is discussed in MSc syllabus. Here we are not interested in that detailed discussion, because CSIR exam specially is very near in June 2023. So from exam perspective, we have to do all the things very quickly so that we can use all the concepts in the related problems of CSIR or SET exams, say, or GATE. Especially these two exams will test the concept of classical mechanics very much. In these two exams, we often see probable questions from classical mechanics. So kinetic energy half and m will be as it is. Here this r dot will remain the same, that means r dot square. But look at the beauty, here two angles are given, and for that second quantity that we are discussing, r square theta dot square, will be there, but this will cover up to this portion, that will be same, but this will cover only one angle. We have to introduce another angle, so we will like to replace r by r sine theta. When we deduce it in theoretical way, we can see that this is replaced as r sine theta. So r square is now r square sine theta. This is the additional extra term, you can say, এটাকে আমরা বলতে পারি এক্সট্রা টার্ম হিসেবে এখানে আসলো, into the last coordinate, that means phi dot square. So in spherical polar coordinate system we see two dot, one over theta, that is theta dot, as it was in case of 2D. The new one is phi dot, phi dot. The new one is phi dot, not double dot. Let us make it clear, not double dot, phi dot. So this is, so especially what are these two are angular velocities, angular velocities, because from x we have x dot, that is linear velocity, রৈখিক বেগ বলবো। একই রকম ভাবে থিটা থেকে যখন থিটা ডট বা ফাই থেকে ফাই ডট, then we call those as angular velocities, angular velocities. So if we just can remember this line, in two-dimensional polar coordinate system this looks like this, and if it is extended to spherical polar coordinate system, this r dot will remain unchanged, r square theta dot square will remain unchanged. The new quantity phi dot square should be introduced by the similarity of theta dot. So we will like to replace r by r sine theta and get the result. Actually the transformation here are used in classical MSc syllabus are these three: x, y, z in Cartesian, when those are replaced by r sine theta cos phi, r sine theta sin phi, and finally z equal to r cos theta. If we make these three replacements in case of x, y, z and apply here half into m x dot square plus y dot square plus z dot square, that is the classical expression of kinetic energy in three-dimensional Cartesian system, then we finally arrive at this particular result. So here, instead of going this details discussion, we would like to just remember this result. Just try to, all of you are preparing for the exam, just like better remember this expression and this expression. If you can remember this expression, then you can easily remember this one also. Just remember r will be replaced by r sine theta. That is the briefing we would like to just here mention. Briefing, r will be replaced by r sine theta. This will be enough to remember the result. Clear? So this is the expression for kinetic energy in polar coordinate system, in three-dimensional coordinate system, which is called spherical polar coordinate system. If a sphere is there and on it we have to just define a particular point, then this is the most useful configuration. Now take a look at one thing. If this r is constant and say this is a, then this expression actually look like very simple expression, because r, if r equal to a equal to constant, then r dot will be 0, and here we have half into m into this portion is 0, this portion becomes, the next portion becomes a square theta dot square, and finally a square sine square theta into phi dot square. So this expression ultimately becomes half into m into a square theta dot square plus a square sine square theta into phi dot square. No need to remember this result, that what happens when r is constant. কোনো প্রয়োজন নেই এটা মনে রাখার চেষ্টা করার, কেননা if we can remember just this result and put r equal to a, then we can easily arrive at this result. So this is very important, because later we will see how CSIR have asked questions on it. Next come cylindrical system. This is another coordinate system. In versus, if we just compare, in spherical polar coordinate system r theta phi, that means we see two angular displacement and one linear. But in cylindrical system, specifically we will like to use three important types. One is r theta z, someone call is r theta z. Here two distances r and z linear and one angular theta. Someone call it as rho phi z, someone call it as r phi z. But basically all these three are equivalent, because in all the three expressions we see two linear displacement and one angular. Here also these two are linear, this is angular. Here also these two are linear, this is angular. So in polar coordinate system spherical we have two angular displacement, where in cylindrical system we have two linear displacement. Just see in the configuration, আমরা এখানে দেখি কনফিগারেশনটাই কি ছিল। এখান থেকে আমরা একটা পারপেন্ডিকুলার টেনে নিলাম, আবার সেই পি এক্স ওয়াই জেডই ছিল, এখান থেকে টেনে নিলাম, এই অ্যাঙ্গেলটা মার্ক করলাম, জাস্ট মার্ক দিস অ্যাঙ্গেল বাই থিটা, অ্যান্ড দিস ইজ আওয়ার আর হেয়ার, দিস ইজ এন, অ্যান্ড ফাইনালি this is z. So one angle theta, one distance r, and from vertical, for vertical measurement we would like to use z. So this type of coordinate system, in this type of coordinate system যদি আমরা মনে করি, imagine just this as a page of your exercise book, just consider it as a page of exercise book. And say it is rotating like this, this comes to the second position, and etc. So cannot we call that just theta is varying? Here theta is this quantity, theta is varying. So the all the motion, if we consider it as z axis, in circular case, circular portion of the motion is about z axis. That means theta is just rotating angle with respect to z axis. So about z axis, we have angular velocity, as we have discussed in our previous lecture. How velocity is determined? Just take a dot of displacement, angular velocity theta dot, that is about z axis, angular velocity about z axis, here is theta dot. We will later see that this particular conception has been asked in CSIR. Clear? So I hope up to this portion you have clear idea of what are the implications of r theta z system. Someone call it rho phi z system, someone call it r phi z system. Then that theta will be replaced by just phi. If someone likes to call it phi, then theta will be replaced by phi, and r and z say they will be fixed. In case someone call it rho and z, then phi will be same, r will be rho, and z will be fixed. So this is cylindrical coordinate system, very important system, another very important system, cylindrical coordinate system. So here kinetic energy in cylindrical coordinate system, that is T always by Lagrangian mechanics, we can easily say kinetic energy is always expressed as in terms of capital T from English alphabet. So half m into r dot square plus r square phi dot, if we call it phi dot, then this is phi dot square, just very similar. Look at the fact, this is r dot square plus r square theta dot square, similar result, r dot square r square phi dot square plus z dot square. But for CSIR point of view, we would like to make it as r dot square plus r square theta dot square plus z dot square. Here the only change is in this quantity. Take a look at the fact. All comes from this simple result. Just remember this simple result. If we can remember this simple result, then everything will be very easy to us for exam perspective, because in exam we have to use time saving strategy. If we just say give 15 minutes to a problem that can actually be done in 2 to 3 minutes, then I don't know what is the idea of 30 second or so. Can anyone solve a particular problem in 30 seconds? That is a difficult question, the answer of which perhaps we do not know. But if a question in classical mechanics takes 15 minutes, then that question may be reduced to 2 to 3 minutes. We can solve it easily. So time saving technique, just remember this result. In spherical polar coordinate system, this is r dot square plus r square theta dot square, half m into that quantity. This is extended as, in spherical polar coordinate system, r dot square is fixed, r dot theta dot square is r dot theta dot square, that is same. Here the next quantity comes, r is replaced by r sine square theta, r sine theta. So r square sine square theta, and new quantity is introduced, phi dot square. But in cylindrical system, in the last portion, there is again another displacement, so that comes here, z dot square. One displacement is linear r dot square and another is z dot square, and the polar portion remains the same as in two-dimensional polar coordinate system. So ultimately those three coordinate system, that means x dot x y z, এটা দিয়েই ভাবি, বা r থিটা ফাই দিয়েই তোমরা ভাবো, বা r থিটা z দিয়েই ভাবো, বেসিক্যালি ভেরি ক্লোজলি রিলেটেড টু ইচ আদার. So again, if r is a equal to constant, এখানেও যদি হয়ে যায়, then that t becomes half into m into 0 plus a square theta dot square plus z dot square. So ultimately this will become half into a square theta dot square plus z dot square. So up to in this video lecture, we stop here by defining kinetic energy in cylindrical and spherical polar coordinate system. In the next video, we will obviously discuss all the important questions from all the important competitive exams like CSIR or different state set exams, etc. So until then, goodbye.